Coefficient of pressure is an important topic, and it represents how the pressure is being converted to velocity or vice versa. So it can tell you about the flow acceleration on the surface of any body, and it can also tell you about any separation or reattachment of the flow very clearly. So that's why the Cp is a very important parameter. And for these type of cases, the Cp is defined as, if you go for the turbine, like low pressure turbines, the Cp is defined with the help of total pressure. But for most of the aerodynamic applications, like the external aerodynamics, the Cp is defined by the static pressure. So this is the P minus P infinity, that is the free stream pressure coming from at the inlet of domain. Like the U infinity, we have the P infinity as well, and divided by 1 upon 2 rho A rho V square. This is also this is a U infinity or V infinity square, and since we have taken the density is equal to 1 and V infinity is equal to 1, so this term will be 1, and also the pressure is also taken as 0 because we have provided the operating pressure, so gauge pressure is 0 at the inlet. So we are left with a minus 2 times P infinity. Okay, but the important thing is that this P infinity is the mean pressure, not any local pressure at any time step. It's not a instantaneous pressure, but this is the average pressure. So what I mean by this thing, let's say if I plot the P static at any location versus time, so we can have the fluctuations like this. So what I want that we should be having the average pressure, that is the average of the every time step like this. Okay, so to do this thing, this is the fluent case which we are solving for circular cylinder. So first thing which you have to do is that, for example, here we have the run calculation. If there is some data like data sampling, I will tell you what is meaning by this. So first thing is that you have to reset the statistics. Okay, so every time data in terms of some variables will be lost, but the everything else depending on the time will be there, like lift coefficient, drag coefficient will not be removed. So I'm talking about this data sampling. So right now sample time is 0, and what I want is that I want for 800 time steps, that is equal to the because one cycle is equal to 40 time steps, so this is for 20 cycles. Okay, so click on run, click on calculate, and it will start to get data for the data sampling for time statistics, and by default you will get UX mean. So let me enable the pen on the screen. So this is we are going to get the by default, but you can include any variable into time statistics. Very simple. So by default, we are going to get the UX or X velocity mean, and then you can get the V velocity, that is the UY. So we are going to get the UX average, UY average, that is the V velocity, and magnitude of velocity average. And also you're going to get the fluctuations in the U and also V. And also you are going to get the pressure X, pressure Y, and total pressure mean values, and also corresponding fluctuations in the pressure. But we just need the P static average for plotting the Cp. So we don't require any fluctuations in the static pressure or velocity for this purpose. Okay. As you can see that the calculation is now complete for 800 time steps. And we've taken the time sampling, data sampling for time statistics only for 800 time steps, that is equivalent to 20 cycles divided by it's a 20 cycles, okay? And the time which we used here is 0.1453. So its time is equal to 116.24 seconds. Okay, so now I will be plotting first few variables here and there, and then I will go for the value for the CP. So right now I'm plotting the static pressure. This is the instantaneous static pressure. And now you can see that we have the another extra field which was not there before, which is now is unsteady statistics. And this comes after when you record data for time statistics. Okay. And if you plot this value, you can see that this value is slightly different than the pressure at that particular location. So because that is that particular time step pressure, and this is the mean pressure. And also we have the mean velocity magnitude, we have the root mean square values for all these four variables: static pressure, velocity magnitude, x velocity, and y velocity. Okay, so now I will be going to user defined, and from here I will be clicking on the custom field function, and then I will be selecting the mean static pressure. And first I will be making is 2 times mean static pressure. So I told you this why this is so. And this is the mean CP. Okay. So now if I go to results and contours, and if I go to the custom field functions mean CP, you can see this is varying from minus 1.23 to the 1.07. Okay. Okay, now I need points. So for plotting the CP, so I will be going to the ICM CFD file. Okay, so now here we have to make a few settings here. So first try to understand what is meaning by this thing. So we have the Microsoft whiteboard, and now for corresponding to every point, that is the function of radius and angle, we will have to determine the value of x and y for every point. Okay, so I will be using the Excel definitely. So just for understanding purpose, so this is circle, and if we start from this point, this point is at the 0 angle. So, and also this should be very much clear when you use the mean values. So the value on the top side and the bottom side, they will be same. So for the 180 degrees, the flow on this, and also on the bottom side, the mean values will be exactly same. So if this is the 90 degrees and this is the 180 degrees, so for this component, this is equal to the x is equal to 0 and y is equal to 0. But at this point, the radius is equal to 0.5, because the diameter is 1 meter, so radius is 0.5. And if I use the tan theta, so this is y upon x, so theta is equal to tan inverse 0. So you can see that if we use a trigonometry and inverse function, so tan inverse 0 is equal to 0. Okay, so I'm going to use these functions like r is equal to x square plus y square under root, and the tan theta is equal to y upon x. Okay, now let me give you idea about this whole thing. So let's say we have the a circle, and we start from this point, and let's say we divide this half part first into the 4 parts, and then further I divide this into the interval of 10 degrees, but starting from the one angle. So this angle is, let's say, is a 45 degrees. Okay, so theta is 45, and for our case we know that the r is equal to 0.5 meters. Okay, so if I use the two relationships, these are the tan theta is equal to y upon x, and r square is equal to x square plus y square. So I know the values of tan theta because theta is known. So tan theta, tan 45 is equal to 1 is equal to y upon x. So x is equal to y. So I can put this in this equation for the r. So r square is equal to 2x square, and from here I can put the value of r is a 0.5 square is equal to 2x square. So from here I get the value of x as 0.3535, and y is also equal to 0.3535. Okay, so why not to write the actual function? Okay, just be careful with the angle. So sometimes the angle axle is taking is in radians per second, so you should be careful with this thing. Okay, so now we have to let's say we start with the theta is equal to, so theta we define here, and the radius is a constant value. This is equal to 0.5. Okay, so I'm going to find the now 10. So I will get the values after the interval of 10. So plus 10, and this will continue for like up to the 180, or maybe I can do it for the like this for the 5 degrees, but this will be more cumbersome. So I think we should be limiting ourselves to the 10. And so we have these all values. Okay, I just want to confirm this thing for the one value, that is the 45 degrees. So this is the tan theta. Okay, so this is the tan and returns the tangent of an angle. So let's say this is 45 degrees. So this is wrong, so it means that we have to convert this value into degrees. Okay, so just add the function for degrees and you will get the name. Okay, degrees. So tangent of, okay, let me correct this. Basically we had to add the multiply angle by the pi by 180, so that is to make them as a radians. Okay, so it works in the radians form. So if I copy from here and paste over here, so this works like a6 pi into 180. Okay, so let's find the tangent of all these values. And just to confirm, we have to use a calculator and just see that the for 100 or 110, what is the value of tangent? So for the 110, tangent value is minus 2.747. So it's correct. So now it is done. So from here, we can show the y is equal to, this is for the x in terms of, this is the y in terms of x. Okay, so this is going to be the, because now if we get the value of y, so y will be equal to this tangent of angle into x. Okay, so this is going to be equal to this value. Okay, now let me do this thing also over here. Okay, Now, what is the equation we have? We have the equation that so this is a y now with us. So we have to just be careful here. So what we should be doing here is that, let's say we have the y is equal to x tan theta. So r square will be equal to x square plus y square. So y square is x square into tan square theta. Okay. So if I take out the x square common, so we have the 1 plus tan square theta. So I have to find another function that is going to be like this. Okay. So instead of doing this thing right now, I think we should be doing first tan square. Okay. So this is this value power 2. Okay. And now we can find out the value of x in terms of the value of x in terms of the, let me show you this thing. Okay, so from here we can say that x square is equal to r square divided by 1 plus tan square theta. So now we add the one column, that column is going to be the 1 plus theta tan theta square. Okay, so 1 plus tan square. Okay, so this is equal to 1 plus this value, and like this. And I will put this value over here as well, so that we can confirm the value. Okay, so we get the x square in terms of this value. So I can get the x square, or x is equal to, so I can get the x as equal to, so this x will be equal to square root of r square. So this r square, so bracket close for this data. So we can add this this thing over here, and then we have to divide this whole value by the 1 upon 10 plus 1 plus 10 square theta. So 1 plus tan theta square, and then close the bracket. Okay, so copy and paste here. So this is 0.353, so this is confirmed. Okay, and now as you can see that the y is equal to here y is equal to x tan theta. Okay, so it means that the y would be equal to x tan theta. So we have the x, now we can find out the y. So the y is equal to x into tan theta, which is over here. So like this, and copy and paste here to just confirm that we are getting the same values. Yes, it is okay. So now we have the x and y values, and you can make the, so this is your own calculator, which you can now create the points on the circle. So I'm going to do this thing. So I'm going to create the points. So point number, so this is going to be the angle 0. Okay, so copy this thing. Okay, just keep the name in this way. Okay, so I'm going to copy and paste over here. So 0.5 and 0. So x is 0.5 and y is equal to 0. Okay, it is starting from here, no problem. So yes, okay. Okay, so this is angle 0. Okay, now we have the points. So let's take a look where these points are created. So these points are in the meshing setting. So okay, we can work with these points in this way. Okay, second point is point 469. So just copy from here this point. Okay, and I found that this method is very cumbersome and difficult to concentrate. So what I did is that, and so first of all, if you take a look here, you can see that what I found here in when I plotted these points. So I want to tell you about the few things here, then I will show you the technique which is more efficient. So we were finding out the points basically on the semicircle, half semicircle, which is on the top side. Okay, so this is going to be the stagnation point. So this is the circle, this is the stagnation point, and we have the wake on the back side. So this and this side should have the same thing. But when I plotted the points were like from here to here. So this is like a 0 to 180 degrees. So what I did is that I have these points are here. So this point and this point is exactly same, but only thing is that if this point is plus 0.5, so this should be minus 0.5 and then 0. This point is a middle point, so total 19 points are there. So this is the 10th point. This point is common point from the both sides. And this point is exactly over here. This is the 0 and 0.5. Okay, so for other points, what I did is that I deleted the points which are here to here, and then I pasted these points. Basically, what I did is that if you change the sign of this number to plus and this number to minus, this will be same thing. So 0.086 minus and then the plus of this value. This is the plus already here, so you can paste it over here and just put the minus sign for every number which is over here. And the second thing is that I have the one command, and this command is that surface. This is the command in the Fluent journal. Surface, point surface. This is the command for creating the point on the surface. This is the name of that point, so you can put the name as a point 1, point 2, point 3, point 4. And then we have the, if this is the three-dimensional point, then you have to provide the x, y, and z coordinates. So this is a 2D case, so we will have to only provide the x and y coordinates. So here I provided the x and y coordinates from the Excel sheet, but that is up to this point. And then this point and this point is the minus of this value. So just copy this whole point and paste over here and put the sign, minus sign here. So similarly, I did this thing. So this is, when you save this file, this is, I'm going to attach this file also in the very first lecture of this section. So when you save this file, so let's say I put the name as create points. Okay, so extension should be .jou. This is for general file. Okay, so take a look here, and you should have these general file. This is for the default file. This is created by the Fluent. So these two files are the same, exactly same files. This is a new file which I created right now. So what you have to do is that now we have these all points. So I'm going to go to manage, and I will delete these points so that I can show you the whole procedure. Okay, so these all points are deleted. And if you take a look on the mesh, you can see only this thing. Okay, now I will go to the file menu. From here, read and journal. And you have to read the journal file, which is exactly same files are both of them. So this will create 19 points. Like this. Okay. So now what we have to do is that we have to go to the XY plot. Either you can use XY plot or you can use anything else. So what we're going to do is that we are going to select these points. Okay, and choose a custom field function and try to plot them. Okay, so we have the position in the meters and then these values. Okay, then these values. So we have the CP also. Okay, try to change the axis for the x-axis from -2 to the +2. This is for the y-axis basically. Okay, and also for x-axis we will do it like it's a -0.5 to +0.5. That's okay. So, oh no. Okay, let's do it again. And we have the one lesson here also. Whenever you work with any case, you should be saving your data. So you can see we lost every data, so I will do it again and I will then come back with all these points. Okay. Okay, so this is the data we have again, and everything else is same. So I'm going to write the data over here. So this is the CP plot. Okay, so I will open inside the Excel and import data points, and this is over here. Okay, in the Fluent new data, and this is the CP plot. Yes. Okay, so we have to deal with these things. All right. So anyhow, I will delete all these cells here. Okay, so I copied all these points over here, and now I'm going to arrange them based on the x value. So from lowest to the highest value. Okay. So cut, paste here. Okay, so this is going to be the x and this is the CP. Okay, so I will sort values based on the column number I and smallest to largest. Okay, so insert and chart. That's very nice. So here we have the scale. Okay, so let me make a quick style. So this is CP versus angle. CP versus angle. So I can say this is the 0, 10, 20, 30, 40, 50. So why not to apply the formula? So 10 plus this value. Okay. So I will select the data and add it, and x value I'm going to put is the angle. Okay, so we have this data set in this way, CP versus theta. Okay, so this is the average CP. Keep in mind this is the average from the average pressure. That's why this is the average CP value, and here is theta. Okay, so I am going to put here. So let's say we make the labels on the bottom. It's okay over here, or maybe you can do it on the bottom side. So low, yes. And here I'm going to put the font size. So let's say we work with the in like this. Okay, so measure is 10. That's great. Okay, color can be the black. And here let's try also black. And this can be deleted from here. And this color can be blue and blue. Okay, you can make it bold. Okay, as far as this curve is concerned, so let's make a black line with some thickness. And as far as the markers are concerned, so let's try with these blocks and increase size. Okay, so we are going to make the fill with some other color. And this color can be the green. Okay, so this is our graph for CP versus theta. Okay, so I will copy this plot, and font color here we can use, for example, red, and you can increase size. So let me copy this graph. And this is going to be the last slide, and I will be uploading the latest graphs also in the file sections, and you can download them. And also I'm going to upload everything, every file will be updated. Okay, so this is our plot. So this is the coefficient of pressure versus theta over cylinder surface. This is the average coefficient of pressure versus theta over cylinder. Okay, so I hope that now I have also added this extra thing, that is the CP versus angular position from 0 to 180 degrees. So I hope that this will help you a lot.